Hi guys, welcome back to eCoreAcademy. I'm Tania and I'm back with the last lesson of our first chapter titled Fundamentals of Algebra 1. In case you didn't already know what we're doing by the title of this video, we're going to be solving literal equations today. Literally, wink wink. But before we get into today's lesson, please do not forget to give this video a huge thumbs up, comment down below, subscribe to our channel, and share this platform with others. Now, without further ado, let's get into this lesson. So you may be wondering what even is a literal equation. And a literal equation is just an equation where letters represent both variables and constants. Some common examples that you might have seen of literal equations would be A equals B times H, P equals 2B plus 2H. That's the formulas of area and perimeter. Literal equations are normally formulas, and that's why they're so always consisting of different variables. But we will be solving literal equations today, and to solve literal equations, we will be using inverse operations, which is basically you just solving for a variable and how you would do that to isolate one. We'll get more into depth with that now. So this is our first example. Like I mentioned before, literal equations are basically just different formulas. So in this case, the formula or literal equation that we're working with is the interest formula. The interest, that is when interest equals principal times rate times time. We're not really plugging stuff in, but when you do see a formula, think of a literal equation. You know, when you solve for different things in a formula, this is what you will be doing. Perhaps you already have the interest value, and we have the principal value, and we have the rate value, but we need to solve for the time value. We need to find out what the time value is. We're going to use the other three values to actually get the times value, but we need to find out how exactly will the other three variables come to equal or create the value of the time variable. And that's where we'll be solving for t in this literal equation. So we have the equation I equals p times r times t, and we're solving for t. So basically we know that I equals p times r times t. I always just like to rewrite it just because it makes me process it once more. You don't have to. It's just an extra step I take. But this is a very simple one. We just have to simply divide by p times r on both sides so that we can cancel it out here and isolate the t variable, and therefore it will solve for the variable t. So this is what I mean for visual representation, if you understand that more. But simply, this is the literal equation for the times value in this formula. This is the formula for the times value when you are dealing with interest, principal, and rate values that you already have. Again, this is very specific, but this is definitely a great example of a literal equation. And you will see as we go throughout that a lot of this will just be a lot of this will end up working with different numbers as well. So you'll see different variables and more numbers and more variables together, and that is how we will kind of build our foundation on working with literal equations as well as stuff that we've done in the past. Okay, so as for the next example, the second example that we'll be dealing with today is the equation or formula p equals 2b plus 2h. And we're going to be solving for h. But before we get into that, I do want to ask you, where does this formula seem familiar from? We just went over it in the other slide, so I did mention it there, but this should be a common one by now. This is the perimeter formula. Perimeter equals 2 times the base plus 2 times the height, and we're going to be solving for the height here. This is very similar to saying solve for x, but just with different variables instead of having different numbers. And we will combine a lot of that later on, and you'll see that, but let's get started with this. So to solve for h, our equation that we have right now is p equals 2b plus 2h. We're trying to solve for this variable right here. So we're going to have to obviously isolate this variable. And the way to start with that is to, isolate it by subtracting 2b from both sides. These are extra steps, which I'm writing for in case you guys would prefer visual representation, but I prefer that you guys do start trying to do it without this part and just automatically knowing that when you subtract, it will simply be a result of this rather than writing that step out, as it does take a lot more time. But that's besides the point. Anyway, as we continue to isolate the variable h, which is what we're solving for, the last step to do that completely is just to divide both sides by 2. And that is another example of an inverse operation. Here it's multiplied and we're just dividing it. So when we do that, this cancels out, and then we have left h equals p minus 2b over 2. This will be this equation solved for h. H equals p minus 2b over 2. And it's as simple as that. All right, so now let's get on to example number 3. So this is what I was talking about before. Literal equations are basically, like mentioned before, equations that only deal with variables that act as constants and different values. Now we're going to be combining our knowledge of using constants of our variable x and more variables, and we're going to put them all together, and we're going to try to still solve for a certain variable, but with our prior knowledge of how to do so with an equation with not only constants and one variable, but 2 variables. So our equation that we're dealing with is 3 times the quantity of x plus 4 equals a times the difference of x minus 6. So the way that we're going to do that is, obviously, we're going to use our PEMDAS rules. We are going to distribute the 3, and we're going to distribute the a on both sides, and that's how we'll just start this process. So when we distribute the 3 on the left side, it's going to be 3x plus 12 equals, and then when we distribute the a on the right side, we'll get ax minus a6. This can be switched around to be 6a. That's more common. I will end up doing that in a bit when we get to the next step, because it helps me with my visual preference. But it's really up to you. As long as you understand what you're writing, you're fine. So we're solving for the variable x. So we know that we have to bring all of our values with x in it to one side and the rest onto the other side. So I like, when I'm solving for a certain variable, I definitely like to always have it on the left side. Again, preference. So we're gonna work with that. I think it's the most common way as well. So the first step to take is to move this value over here with the x from the right side to the left side, so we can start isolating the x values to the left side. So we have minus ax. I'm not going to write down this step, but we know that 3x, subtracting it from both sides, cancels out here, but it adds, but it subtracts on this end, meaning we have to write it in here. And so we have that. And then plus 12 equals negative 6a. So now we know that the last step from to actually have all the x values on the left side is just to make sure that we subtract 12 from both sides. And when we do that, we know that it's going to be 3x minus ax equals negative 6a minus 12. All right, now that we have all of our x values on the left side, we have to obviously, since there are coefficients attached to different x values, we need to get rid of those coefficients. We're going to start with the fact that we can pull out an x from this expression here. We can pull out a x from 3x minus ax. So when you pull that x out, we just get x times the quantity of 3 minus a equals, we can do the same thing here. We don't have to, but we're going to just because maybe it'll give us more practice. But again, you're going to end up at the same answer with whether or not you do it. Maybe this is a quicker step. So we know that we can pull out a negative 6 as negative 6 is a multiple of both negative 6 and negative 12. When we do that, we get negative 6 times the quantity of a plus 1, or a plus 2. If you want to double check, we can always just distribute this in our head to make sure we get that. So 3x minus ax, negative 6a minus 12. Simple as that. Quick work. So then after that, using our inverse operations, we know that since this is basically a coefficient of our x here, we have to divide this on both sides. When we do that, it cancels out on the left side and goes underneath the right side. So at the end, we get negative 6 times a plus 2 divided by 3 minus a. And we can call it a day. This will be our final answer for when we solve this equation over here for x. It's as simple as that. Here we kind of just combine the idea of solving normal equations with more than one equation, which is where that literal equation idea comes in. But this is nonetheless building more practice. And again, from Algebra 1 and now, it's not only going to be one constant idea, it's going to most likely be additions and the use of so many different ideas all into one. So you'll see that all integrate together. So that was example number 3. Now to example number 4, same deal here. This is an actual formula though. The other one was quite random, I believe. So this one is an actual formula. This is the Celsius formula of how you can find the Celsius value or the temperature when you have the Fahrenheit temperature. Again, we're not working with specific numbers here to actually find a specific Celsius degree, but we're going to use these helpful formulas and equations to aid our practice today. So anyway, today for this example, we are solving C equals 5 over 9 times F minus 32 for F. So again, I like to write it down again, especially because this is kind of horizontal. I would just like to write it down vertically, and then F minus 32. So we're solving for F here, right? But the thing is, since F is in here, we need to let it be alone. And the only way we can do that is to get rid of the parentheses. but the only way we can get rid of the parentheses is if we distribute the 5/9 to both of the terms inside. So C equals 5/9 F minus, and then I'm trying to cross multiply here, but what do you call it? 9 and 32 simply do not have a common multiple or a factor that they will cross multiply by. So we simply just have to multiply the numerator with 32 and put it over 9. So 5 times 32 will be 160 over 9. And that's just a simplified version of that. But like I said, we are solving for f. So again, we want to start isolating this variable. Next step we have to take is to actually add 160 over 9 to both sides using our inverse operation rules. So when we do that, we get C plus 160. Excuse me, I would like to quickly erase that because that was my bad on my handwriting. 160 over 9 equals 5 over 9 times f, 5/9 f. And now that we have our f values on the right side, our last step is to get rid of this and actually completely isolate the f. The way we do that is to use our inverse operation rules, and since we're multiplying f by 5/9, we have to divide both sides by 9 over 5. Like we learned in pre-algebra, when you have a fraction, we just have to, a fraction as a coefficient, you just use that as a reciprocal. Instead of taking your time to do every single step, this will be the most efficient. So we'll multiply both sides by 9 over 5. I think I said divide both sides. I do mean multiply both sides by 9 over 5. And when we do that, we know that this cancels out. So we know that the f is all alone. So we are successful on that side. But now we have to distribute the 9 over 5 to both the c and this term, 160 over 9, because we've distributed all terms that are there. So when we do that, we get 9, 5, 9/5 c, plus, we know that we can cross multiply here. We know that this is going to cancel out, so 1, 1. We know that this is also going to cancel out because 5 fits into 160 32 times. And we know that 32 times 1 is 32 over 1 times 1 is 32. So 32 equals over lonely f. So basically, we know that at the end, when we solve this equation for Celsius here, for f, we're going to actually get this equation over here. And this is how we kind of use our ideas of solving for a certain variable when there is more than one variable and there are constants and there are coefficients. And so now we're just building our knowledge more and more, and we are doing pretty great. So now for the last example, we have another random equation, but still we're practicing our ideas of we're still practicing the idea of working with more than one variable, constants and coefficients, and still solving for only one variable. So our equation here is 6m plus n equals 4/5 times m plus 7, and we're going to solve that equation for m. Again, because of personal preference, I like to rewrite it. 6m plus n equals 4/5 times m plus 7. We're solving this for m. We know that there's an m here. We know that there's an m here. We know that we have to start, when we solve for something, we're going to have to isolate that something on one of these sides. Again, preference-wise, I like to isolate my something on the left side, but in order to isolate this, which is my something, in this case the m, I'm going to have to distribute the 4/5 to both terms in this parentheses set. So it's going to be 6m plus n equals 4/5. Excuse me. Four-fifth m plus 28/5. So the next step to do is to put all of the m values on the left side, or something values on the left side, and the non-something values on the right side, meaning we're going to subtract 4/5 m from both sides, which will give us 6m minus 4/5 m, and we're going to also subtract n from both sides, which will give us 28/5 minus n. And that will kind of be our simplified version. But from here, we have to, like we did before, or in the previous example, we have to further simplify this and try to find a common coefficient between these two terms so that we can bring it over and isolate the variable m. We know that we can pull an m out here. But instead of doing that, since we have real numbers here, we can also just simply subtract 6 minus 4/5, which will be 5 and 1/5, which in other words is 26/5. So 26/5 m equals 28/5 minus n. And like we did before, we're just going to multiply by this reciprocal over here. We're going to multiply both sides by the coefficient's reciprocal, which is 5/26. This way, our something value, our m value in this case, will finally isolate itself because it'll cancel out here, because the coefficient will cancel out here. And we will finally be able to solve for x when we distribute the m's coefficients reciprocal to this side of the equation. And we have to distribute to both terms. So to do that, we know that we can cross multiply here. 5 and 5 will cancel out. 28 and 26 will cancel out to be 14/13 because they'll simplify. So we can rewrite it here. So there's a little bit more space. M equals, we got 14/13 minus, and then since there are no like terms here, we can just say that the coefficient here is 1 in front of the n. And just multiply it by 5 times 26, and we can just multiply -1n times with 5 times 5/26, and that will give us 14/13 minus 5/26 n. Sorry for that jumble mess of words. But here is our equation when it is solved for the variable m from this equation. And it's as simple as that. So here's all the work if you need, copy it down. For this one, I will say I did a lot of it more mentally. I didn't write each and every step out, but I did say it as I went. So if you need more understanding, I would definitely go back to listen to what exactly the thought process was. So guys, that was the end of today's lesson. We have done 5 examples, not only on literal equations, which was the main idea, but we also built something new with our skills. We started working with one equation having more than one variable with constants and coefficients and all different sorts of numbers, which is a new thing. Well, it really isn't a new thing, as this was learned in pre-algebra, but it was a new thing to this course. So I'm glad that we have concluded our first chapter of our Algebra 1 course here at eCoreAcademy, the fundamentals of Algebra 1, which is just a review of our pre-algebra topics that will probably be most and heavily used in Algebra 1. But now that we can say that, I hope you guys had a great time with this video. I hope you guys could find it helpful. Here is the website link and our email in case you guys wanted to reach out to us, as well as our other socials. We have Facebook, Instagram, and Twitter. Please do not forget to like this video and subscribe to our channel. Also, comment down below any comments, concerns, or questions, and we'll see you guys next time. Have a great day, guys. Thank you for watching.